On average, we spend 90% of our lifetime indoors. The indoor air quality thus has a major impact on our well-being, our performance, and our health on a daily basis. Ventilation systems and especially air handling units are needed to ensure healthy indoor air quality. So why is an air handling unit the energy-efficient backbone for our well-being and health?
My name is Oliver Topf and I'm Product Manager for Performance Device at Belimo. The quality of indoor air can be measured, among others, by the temperature, by the humidity and the CO2 level. Healthy indoor air quality is given if these values are within a certain range or certain limit values are not exceeded. We achieve this by supplying fresh and treated outdoor air and the removing of used indoor air. In modern buildings, these tasks are performed by air handling units. Let's have a look how this looks like. Here we are in a technical room in the basement of this building. Behind me you can see a centralized air handling unit designed as an air conditioning system. This unit has the task of intaking fresh outdoor air, conditioning it regarding temperature and humidity, supplying it to the rooms of the building and removing the used air. The ventilation rate and the required level of temperature and humidity are based on an overall heating and ventilation concept.
The outdoor air and exhaust air dampers are opening. Fresh and untreated outdoor air is sucked in by the rotating supply air fan and is transported through the air handling unit. First, the air is filtered. This means that the outdoor air is freed from impurities and pollutants. Subsequently, the air flows through the plate heat exchanger and is then conditioned according to the requirements. In winter, the air is heated in the air heater. In summer, the air could be cooled in the air cooler instead of being heated. Finally, the air is humidified with a steam humidifier if required. The conditioned air is supplied to the rooms and zones according to the demand. At the same time as the supply air is blown in, the stale room air is extracted by the extract air fan. When entering the air handling unit, the extract air is filtered again. This prevents contamination of the air handling unit itself. The extract air then flows through the plate heat exchanger. This transfers the heat from the extract air to the supply air, thus saving valuable energy. Finally, the exhaust air flows out of the air handling unit via the exhaust air damper.
A modern air handling unit controls the airflow and the temperature as well as the humidity in an energetically optimized way. In addition, certain start and stop sequences as well as safety states can be handled. To make this possible, various field devices such as actuators, valves and sensors are required.
Actuators are required to control the outdoor air and exhaust air dampers. In many cases, fail-safe actuators are used so that in the event of a malfunction, the supply of fresh air can be safely cut off, even without power supply. Actuators can also be used to control the transfer capacity of the plate heat exchanger. By opening and closing the thermal bypass, either less or more heat is transferred from the extract air to the supply air. Control valves with actuators control the supply of cold or hot water to air coolers or air heaters. The power output of the heat exchanger is ensured by demand-based flow or power control. Various sensors measure the physical conditions of the air in the air handling unit and pass the information on to the controls. Important sensor types are differential pressure sensors, which, for example, measure the pressure difference across the filter or across the fan. From these values, the degree of filter clogging or the flow rate of the fan can be determined. Temperature and humidity sensors measure the air conditions and help the air handling unit to condition the air accordingly or serve to monitor the individual measured values in the event of a fault. Air quality sensors detect the air quality and ensure that the air handling unit can provide the amount of fresh air according to the demand in the zones and rooms.
These field devices are used to control and regulate a wide variety of processes and functions inside the air handling unit. In many cases, these field devices are involved in interactions, and only in this way an air handling unit can be operated in an energy efficient manner. On one hand, the air handling unit ensures that sufficient and fresh outdoor air is supplied to the rooms in the building. Only then we feel comfortable and stay healthy. On the other hand, actuators, valves and sensors ensure that this process of air conditioning and supplying can take place in a demand-oriented and thus energy-efficient way. Therefore, an air handling unit forms the energy-efficient backbone for our well-being and health.